Okay, good morning everybody. Let's start today's stream, and I'm gonna pick off right where I left off this Friday. And I think that was in the process of patchifying the terrain. Good morning, Sudo. So instead of this square just being one mesh, we can now split it up based on some setup here. So right now we have a subdivision of 2, but it doesn't get created entirely correct. So this setup, what we have here, comes from a dimension of 10 times 10, a resolution of 10 times 10, and a subdivision of 2 times 2. So the subdivision works, we get 4 planes, but in total we only have 8 times 8 in resolution, and dimension I think we have the correct as well. I think it's 10 units, i.e. meters, on each side here. So it's just a little miscalculation during generation of the terrain patches. And I think I think we got to the bottom of it just before I had to run away, and it is most likely these. So we're doing up to 1 less than resolution X and Y. We probably need to remove the -1s here, or actually, yeah, remove the -1s here, less than and equal, and here we do just resolution X. Well, that was the guess at least, but I think that is true. So it is the resolution. The resolution is the only thing that doesn't entirely work. So the question is, do we need to do +1 here then? Probably yes. Yeah, it should be okay. So I think we're just gonna run with that, see what result we get, if we get an error or not. Oops. And UVs, we can probably just create this one as, or I think this is it. Let's just do length here. Oops. And once again, it's Monday morning. One needs to warm up a bit. So we're doing this real slow, but it feels nice. Okay, so that's this loop fixed. We added 1 in every direction to the size here. So now it's just this one as well. And yeah, looks a bit nicer. So let's try it. We're a bit off. Very interesting result. In this direction we're okay. We have some error with the mesh collider as well, do we? I think so. Okay, so it works in the X direction, I think it is, but not in the other one, and that is because I think it has to do with this one. Okay, great. Let's see. Quad. Just want to compare real quick. 10, 10. Yes, so the size is correct. What's up, Jose? The size is correct, the resolution is correct. Nice start of the stream with a quick fix. Yeah, it's a good note to leave on. Like, you have a problem on Friday afternoon, you have a problem, you know how to solve it, but you leave it for Monday morning, you know. You need to start that new week in a correct way. Thank you, Jose, but this issue was actually Fabic's work, or like he was the one pointing out what was probably wrong last Friday. Sudo, one question, bro, please. May I ask you if you are a professional developer out of Twitch? No, I'm not. I don't work as a game developer when I'm not streaming here. Thinking about it though, maybe pick up some freelance work, you know. Okay, amazing. So now we have thank you, Jose. Sorry about the pronunciation, by the way. I appreciate it. It would be amazing to be able to do this full time. I'm just not, like, if I'm gonna be honest, I don't know how well I would handle having like more than one game in my mind at the same time. Like, that's the biggest issue I have, like working on one game on my free time and another game professionally. It feels like that would lead to me doing two games half-assed instead of one game. Yeah, so that is one of the reasons I'm not developing game professionally on the side of this, because I've tried doing something similar previously, like having more than one game in the air at the same time, but it's hard. Appreciate it. So, okay, good start. Quick fix on a Monday morning. So what do we have? Implement custom terrain solution, create public class terrain base, generate multiple terrain patch as in terrain base. And here also Fabic left me some very good links to like a different approach we're gonna try later, which hopefully will lead to better performance. We'll see. I'm pretty sure it will. But we're gonna start simple first. So now we have terrain consisting of patches, so let's try and up the dimensions a bit here. So let's go back to, I don't know what we had on. We had 80 times 80, so let's try, or 160 times 160. So let's go with 160, 160. And I don't know what the resolution should be. 64. Is 64 times 64 okay? And then we subdivide it 2. Let's see if this works. 256 would be very nice. Let's try with some weird values. The reason I took the reason we choose these values are because when we developed the grass shader, we used a, let's see here. We used a plane that was 64 times 64 vertices, and it was scaled to 80 times 80. So, like, I'm trying to replicate those dimensions. One sec. Damn, I had a pretty relaxing weekend, but this virus that is wrecking me doesn't seem to want to let go. But okay, let's see. So I wanted to replicate the plane we used for the grass shader so we can get a similar grass visuals as we previously had, if we choose to apply grass to this. Thank you, yeah. Slowly but surely. Okay, very nice. Extremely nice. Yeah, let's do this as well. Minimum, max 10. I'm definitely learning by watching you work, so thanks for sharing with us. Oh, nice to hear. Okay, so what we have here is we have a height map, a height texture, which describes like the Y position of the vertices. And right now we just have one height map, and we apply the same one to each patch. That's why we get this weird line here in the middle. Although I am a little bit surprised. I didn't think we actually generated this height map with it being a creases. That's good. We actually generated this height map with being repeatable, but it looks a little bit weird because the normals are not. So although the vertex positions are the same for this patch here and this patch here, the normal is not. So you will need to stitch the patches normal. Yes, indeed. So yeah, so it's a normal issue. And this is, I didn't know exactly what I was going to do today, but today might be the day that that we, like, these patches should be able to talk to its neighbors, right? I think because the idea in the future as well is that this patch will have one height map, this patch will have another height map, but we still need to talk like the normals here. And that also makes me a little bit worried, because that might mean that we might not be able to rely on this, right? Can you explain a bit about what are normals and why they are shaded a certain way? I can try. Let's see here. Are we having some problem with the mesh collider as well? No, I don't think so. Okay, let's see if I can bring up some drawing software, so I can do some small, so I can try and explain this real quick with some with a drawing. So right now we generate a terrain, and the terrain consists of quads, which consists of triangles, right? So we generate vertices, and then we define how these vertices creates triangles, and then we use the mesh.recalculate normals method to calculate the normals of our generated mesh. And the normals are, what is it, a vertex that is perpendicular, I think it is, to the surface. So it's like a vector of size 1 or length 1 that is perpendicular to the surface. And normals are used for a lot of things, but most for doing proper light calculations. So if we have the sun here and this one sends out light here, we use the normal to calculate how much light should the material absorb, or we do a more optimized way to calculate it. Like it's a, what's the word I'm looking for? A simplified way of calculating the light. No, we're not into ray trace territory. We currently use a simple, actually this is Unity, a Unity material, so I don't know exactly how the light is calculated here, but it's some physically based rendering. But the normals are used to properly calculate the light of this plane, like how it should be shaded, and that's what we see here. So if I just copy this image here and we take a look at this point here, for this patch the normal of this point is calculated based on this vertex, this vertex, this vertex, this vertex, and this vertex maybe. So how it should be, in what direction it should be pointing, and it's probably something like this. But if we take this side and we take the same vertex, the neighboring vertices are positioned a little bit differently, which means that this normal is probably more in like this direction, and that's why you get different shading here than here. Yeah, exactly. Blinn Phong lighting model is like one of the I was about to say oldest, but it's probably not, but like one of the most well-known, I think. But yeah, Blinn Phong, definitely check that. So we actually use Blinn Phong for the character lighting. So to calculate the correct lighting for the character, we calculate a Blinn Phong lighting, and then we just truncate the colors, so we get these sharp edges here instead of gradients. It's very nice. Yeah, the solution here would probably be to make the different patches talk to each other. So when we calculate the normal for this point, we calculate the gradients asking this patch for its neighboring vertices, and then we use them as well. Like, that's one way to do it. I'm not entirely sure that's the best way to do it. So it basically comes down to this vertex needs to know about these vertices, so the neighboring vertices on the other patch. That's what it comes down to, I think. Yeah, so that makes me wonder, maybe we want to do so we have terrain patch, maybe we want a function like set terrain data, maybe we want to do something like public void calculate normals. I do like this one. We're gonna double check, see if there already exists something we can use here, but otherwise it would probably be calculate normals, vertices, and then we have like vector 3 left neighbor vertices and so on. And then we use all of these to calculate the normals. That's one approach. I feel like I understand how games work, but when it comes down to actually implementing solutions to problems, I don't know code well enough to execute my ideas. I can definitely relate to that. I used to be in the same position pretty much, and I just grinded my way out of it, to be honest. Like, I had this thing I wanted to implement. I knew roughly how to do it, but like actually doing it in practice was just a grind, like bashing my head against a wall. A little bit like we're doing right now. Good morning, Geralt. Hope you had a nice weekend. And morning, Harukadan. Same to you. One sec, blow my nose. Okay, so we need terrain patches to talk to each other, if not for properly fixing the normal calculations. We're gonna need it later on when, so each terrain patch is going to have its own height map, and we are probably gonna use the height map. Let's see here. I think we're gonna use the height map, or one of the channels in the height map, for use in our navigation solution as well. So when a entity want to navigate from one patch to another, they need to talk as well. You will only need neighbors, first row and column, and last row and column data. Yeah, that's definitely true. So but let's do it like this. Let's start off slowly. So let's just instantiate the neighbors correctly first. I wonder, like, I probably want to have, actually, let's do serializable, but let's do it like worst case scenario when it comes to the neighbors is, like, we actually need okay, let's see here. So if we have let's say that we have this terrain and it consists of 4 patches, and we have okay, very nice. Would probably be quicker to just visualize this in Blender, but so you can always make the mesh bigger by 1, generate it and remove those extra verts and triangles. Yeah, the reason I want to go with a patch solution is I think I want, like, it feels like it opens up some nice ways to do some optimization, you know, with like, if we're far enough from one side of the terrain, we can take that patch and switch it to a model that is represented by way less vertices. Although the question is if we need something like that, if we're gonna, like, what we're gonna utilize in the future. Render Goblin, what's up? Good morning, what are we doing? We're doing terrain, so that was a good guess. But okay, so let's say that we have these patches, so each patch actually needs to know about 8 neighbors, right? Because when we calculate this vertex, we need to know about these, like the slope here, here, and here. I happen to be a self-talk expert. Fuck, I'm starting to think that tea might not be enough for this shit right here. I might need a warm cup of coffee for this. Or hot is maybe the best word for it. I need the good stuff. Do you plan to use height map images? Yes, indeed we are. So I can show you what we got right now, Render Goblin. I do have hot tea here. Good morning, Cypher, by the way. But I need more caffeine. So this is what we have right now. We have one big terrain patch, which consists of 4 patches. Each patch is going to have its own height map. Right now they have all the same height maps. And we're currently talking about the difference in normals here, which makes the shading look a bit weird. And like, first of all, it's a question of like patch-based terrain. Is it old news or not? I'm leaning against wanting to use it. But if we want to go a patch-based approach, then we want to be able to communicate between the patches, so that when we calculate the normals, we do it in the correct way, right? So when we calculate a normal for a vertex here, so it's a macro problem and a micro problem. The macro problem is that the patches needs to be able to talk to each other and transfer information about vertices, right? Nope, no communication. You just give each patch a little extra edge data or clip maps. But each patch a little extra edge data, isn't that communicating? Because you want the extra little edge data you give are this patch data, and you give it to this patch. And clip maps, no idea what that is. Ooh. We're gonna check into that one. Love. Oh, let's save that link. Terrain rendering using I guess it's from GPU Gems. I love GPU Gems. It's amazing. Calculate normals for each patch's vertices. Interpolate and normalize normals along shared boundaries. Definitely. I use instanced vertex texture fetching, but I haven't added in LOD on the distant patches. Oh, very interesting. So, like, the reason I'm leaning so heavily against communication between the patches is partly because like these terrain, we're gonna pack a lot of data into the terrain. So right now, let's see here, notes, thoughts, let's do thoughts. Yeah. Let's see here, data packed in terrain texture. So 1, 2 R G B A. So like we have a terrain texture. Right now we only use the red channel, and that is for height map. The idea is we're gonna pack a lot of stuff into this texture. So each patch will have one of these texture. So terrain patch texture. One thing here, it's going to be used for, let's see here, navigation information. And when I say navigation information, that is going to be information we need to implement a simple A-star navigation algorithm. And like if we have an entity moving from this patch to this patch, we're gonna need some communication as well, right? What sort of data you want? The least amount of data possible for good performance. Yes, definitely. But we also need this data for the game to actually work. Jose, can you generate the terrain using the golden ratio for an infinite terrain using pleasing generation? It would be real CPU intensive. I have no idea. Golden ratio for infinite terrain. So show terrain. Make it work, then improve it, definitely. We're moving slowly. So like the idea also is that we're not gonna do procedural generation for environments is not something that is planned for the base game or like the vertical slice I want. Pretty much the vertical slice will only consist of the garden, so we won't really have any procedurally generated terrain. So the garden will start off as, I don't know, a mountain of trash basically, and then it's up for the character or the player to clean it up and such. So the initial height map will be decided by me, manually made by me, and the height maps after that will always be user generated. So the user can run around in this terrain and terraform it. So at this state we're not gonna put too much energy into procedural generation because we don't really need it. I do love it though. And yes, like we're gonna try, like what Fabric said, like make it work then improve it. That's pretty much the approach we're gonna take here, because like my experience with terrain is slim. Next to none basically. So we're gonna do this slow, like move forward slowly, implement what we need, and then try to scale it without removing any functionality. So I know right now we're using mono behavior, which we might want to skip later on and rely on something like this instead of mesh filter. Thank you, Jose, and thank you for being here and interacting. It's appreciated. So yeah, each patch will have a texture with data. Navigation information though, like this is something that that also depends. Like, do we want to do and is it possible to do AI navigation on the GPU? Like, everything is pretty much possible, but is it a good thing to do? Because like, if we want to do AI navigation on the GPU, then we might want to send in this channel as well. So that depends. Like, each terrain patch has a texture of data, R height map, G navigation information, but do we want to send all of this to the GPU or not? Yeah, that's a question. You can easily make a star with burst. Yeah, so like that video I watched this weekend, that was pretty much my introduction to burst. I've heard it before, never done anything with it, but yeah. Render Goblin, AI navigation should be a separate system like a collision. Yeah, but AI navigation is going to depend on the terrain, right? Burst is easy. Nice to hear. Yeah, we're gonna deep dive into burst as well. But so I understand that AI navigation should be a separate system, so the terrain this is like how the terrain needs to know. The terrain is going to affect navigation information, so I think we still want it here. You will have no problem understanding it. Thank you, appreciate it. But we'll see. I'm probably gonna do it on stream. So like what you have shown me so far, like the terrain generation you sent me and the videos you sent me, like that's all the knowledge I have about burst, or like everything with burst I've consumed, and it definitely seems to be. It definitely seems like it will be useful. I appreciate it. Navigation must be coded after the terrain generation is nice and smooth, so that collision is smooth as well. Yeah, so like I think we have I wonder if I have it with thoughts here. Yeah, this one. It was also like right now when we generate the terrain, we generate a mesh collider as well, or like we add the mesh to a mesh collider component as well. The question is also if one could skip doing this and just do a custom collision system using, oops, what did I do? Using this data. By the way, I rewrote the whole terrain generation and destruction. What? Was it something wrong with the previous one, or is it like much better now? It's even better. But I'm starting using unsafe code. What does unsafe code entail? Like, I appreciate it. We'll check it out. I think collision based on height map data will make the experience seem cleaner. Yeah, like I think it's way more. I think it can be way more optimized that way. but I don't know if it's possible. It would be very nice. Like when we check collision against the terrain, we just want to check it in the Y direction, basically. So an entity that walks around on the terrain has a world position XZ. So we take the XZ and then we get a height map value, and then we compare the Y position with the height map value. Would be nice. Let's see. Render Goblin, well, AI navigation using tile-based regular grid sounds fine, but there is no reason to send it to the GPU at render time. Unless we're gonna use this, like if we're gonna use computation shaders, then we want this information on the GPU. It's like we're gonna do it this way right now, and then we can pick and choose what information we send or not send to the GPU. So for instance, if we look at the terrain patch, we're gonna probably gonna want to make this into a class as well, but we're gonna have terrain data. So each terrain patch is going to have terrain data, and each terrain data is going to have a texture 2D with this information. Decisions. Let's see here. But so the question is, that we're probably gonna have to do this ourselves instead of relying on this one. If we calculate the normals, however, we might be able to do this one. How do you know what tasks to allocate to GPU or CPU, or does that fall into some sort of physics rabbit hole? It's basically, it's the simplified, let's see here. It can pretty much be simplified down to the CPU is extremely good at doing complicated tasks. The GPU is extremely good at doing simple tasks in parallel. So when you have problems that can be solved with a parallel solution, it's usually better to let the GPU handle it, and then let the CPU handle the opposite type of problems. But previously, and that's with the introduction of computational shaders, because previously you just let the GPU do all the render related stuff and let the CPU do everything else. At least in my very simple outlook on this. But so that's like, when it comes to navigation, there exists some very nice algorithms that can be done in parallel. So if the GPU could handle this, it would be nice. But then also, like, if you let the GPU handle some of the game logic that means that the GPU will have less time on the actual rendering. So it's always a pick and choose as well. I've sent you an example of unsafe code on Discord. Beautiful. Ooh, do I dare? Yeah, it should be okay. Ah, okay, I get it. So it's the unsafe pointer stuff. Oh. Yeah, it was images of code. Cartoon SSTV, do you have any tips for succeeding in a C class? So like the programming language C? I don't know if I have. You can approximate tangents and normals pretty easy in the vertex shader depending on implementation, so no need to worry about that too much. That is true, maybe. How would you approximate tangents and normals in a vertex shader? Like a vertex shader only has access to one vertex at a time. You could do it with the help of the texture. That is true. Yeah, programming language C, design of large programs in C. Like my only experience with C is a very short university course. Haven't done any large programs in it, so I'm sorry, I can't really help there. I remember I came from a like object oriented, so I learned programming through a object oriented language, so jumping to C was a little bit weird after that. Can you give the vertex shader access to more vertices to calculate better vectors? I don't think. No, I don't really have that. You could do it, but I don't think you want to do it. And I do think that we want to calculate the normals on the CPU because we want to do this once. We don't want to do it every frame later on. So we want to calculate it on the CPU. So every time we do some terraforming, we recalculate the normals for the affected area. And then we update the mesh data. If we would be approximating normals and tangents on the GPU, given the terrain data texture, then we would do it every frame, and that would probably not be very good. But let's see. So let's calculate normals ourselves. So we want to do. Let's start easy by just doing it with the vertices we have. So here let's do. Do I want to do it in a separate function? What's up, Mechazonis? I'm good. I have this. I'm a little bit sick, but not sick enough to not be able to do any work. So right at that middle line. But other than that, I'm good. How about you? So let's do a simple calculate normals. Fuck, do I want to do? Yeah, let's do it like this for now. Maybe not the best way. Calculate normals. So we want to replace this one with mesh.normals is equal to calculate normals, and here we do vertices. And we do. Whoa! It gave me, oh, there we go, beautiful, dot length. And we end with returning normals. So let's see if we can make this work. I wonder if I want something like is within is in bounds. What are we doing? We want to do this now, right? Resolution.x and okay, great. I need to get used to the help we're getting here. It's pretty good. Let's just do inbounds. Microsonis, I unlocked a few problems I was suffering on, like I've had a project I hadn't organized enough so I couldn't really trace back the problem easily. But since this problem is solved, I'm very fine. Oh, nice to hear. Nice to hear. Yeah. I know there exists a few very good resources on calculating normals based on gradients. Which I should probably use. But you basically want to do, let's see here. So to calculate the normal of this vertex in the middle here, you want to take all the neighboring vertices and then you want to compare the gradient in that direction, that direction, and that direction. And these three gradient vertices are what you want to use to calculate the normal here. Right. You could probably just do with these two, but might as well, right? That's an approximation depending on what you're trying to do. If you want a true normal, you would sample 8 points and average, not 3 gradients, 2 or 4. But you want to sample 8 points and do the gradients between them, right? You want to get the slope value here, the slope value here, the slope value here, and then you want to create the normal based on those slope values. Right? Because remember, this point, none of these points has a normal right now. So you could do bottom left to top right just like this. I don't know. Yeah, I think I want to do. Don't you want to do this for the best result? You want to utilize or am I? So just this. But are we... Oh yeah, so like this. Yeah, of course. So yeah, this yields a good result. This yields the best result. So yeah, 2 or 4. You're correct. I missed this one. That is true. And yeah, it seems weird to ignore these points. If we do this, we include all points. So when we calculate the normal here, we do this point minus this point minus this point minus this point, and this point minus this point. And then we use those values to calculate the normal, or get the normal, right? Left to right, top, bottom diagonal, diagonal both ways. You're welcome to look at the shader in my game if you want to see an actual live implementation. Yeah, I would appreciate that. At least later on off stream. Just, you know, like, compare. But okay, let's see. So, yeah. We want to do... Let's see, so... How about generating one big mesh, then dividing it into patches? Yeah. I think that would be a very good approach, but I'm worried that when we start messing around with when we start terraforming the terrain in real time, we're still gonna need to be able to recalculate normals based on like changes. So let's say that our character goes up to this hill here and he terraforms it downwards. We need to be able to recalculate the normals with patches in mind, right? Yeah, one could implement, like, we could just do an if statement, so we could have, but like, these calculations are going to happen once on startup, and then for very small areas when we terraform in real time. So yeah, it depends. Maybe this is overkill for the visual result we get, and this is enough. If you just do it with 2, by the way, so if we have this gradient and this gradient, then you just do cross product between those two, right, to get the normal. But if you have 4, do you do cross product between this one and this one, and then you do cross product between this one and this one, and then you do interpolation between the two results, or once during startup and again only on the spots affected by terraforming seems like a good way to go about it. Yeah, I think so. And that's also, unfortunately, the reason that we can't generate one big terrain and then split it up, because we're gonna have real-time terraforming. But yeah. So calculate slope, calculate slope, calculate slope, calculate slope, and then cross product. But what if... Okay, so the most simple way would be... one sec. So you could do this. There will exist points that are at the end of the terrain. So, like, this is one patch. Here you have another patch as well, but here you don't have a patch, and here you don't have a patch. So when we calculate for this point, we don't have a point here, 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 or here. So we can't really do this, and this, and this, and this. So what we do then instead is we can take this point. Later on, we're like, this is the edge case number one, but we don't have this one. So for this one, we just 2 vector up, or Render Goblin. The best performance is produced by keeping your terrain patches somewhat small, so that the GPU benefits from post-transform vertex cache and reduced memory fetching. So smaller patches of terrain perform well due to memory fetch or vertex cache, depending implementation. For example, several 16x16 or 32x32 terrain patches will probably perform better than patches with 64x64 or 128x128. I would probably want to do some performance testing here, so like it would be nice to implement this in such a way that we can simply and efficiently test, like find the perfect spot of performance versus patch size, you know. But so let's see. Inbounds, we want to do private bool inbounds x. Private bool inbounds. Damn, this new helper, it's real quick. Real nice. And then we do very nice. Yeah, we want to develop this so we can switch between 64x64 patches, 32 and 32 patches, and 16x16 patches. And then we're going to check do some performance measuring, you know. Okay, so let's call them, let's use good names. So we do up to down, or actually north to south is equal to is I think we want to do something like this. In bounds y north to south. So we do actually 4 int I is equal to 0, I is less than do I want to do, yeah, let's do dot x so I think I want to do, let's see here, is equal to inbounds y, here we do j plus 1. If it is, we check get vertices. I want to create one more nice function up here. Don't worry about performance. I calculate 51 times 51 times 51 nodes on terrain destruction, and it's only one chunk max. You can edit it. It's 4 chunks, and there's no problem. Very nice. Yeah, we're gonna get the logic in place, and like I think it's a good thing to always keep performance in mind, like have it in the back of your head, so when you implement something you can see, oh, here is a possible performance improvement we can do later on if we need to. But spending too much time on performance early, yeah, that's probably not a very good idea. Render Goblin, I currently use 17 times 70 verts per terrain patch because I want data to align, power 16 times 60 worth of data. I'm not worried about the edge of the world. 17 times 17, that's a odd number to choose, right? But the reason for it is because you have some additional edge vertices, but only on one. Like, what made you choose 17 times 17? And Render Goblin, not spending time on performance is why lots of early access games have crap performance. Might be true, but they're also early access. The truth is, everything can be improved. Indeed, it is Fabric. Oh, how many times that mantra have been in my head. But like, when we did the grass shader, do we have it here? Procedural grass light. When we were developing this one, we were always like putting up notes. So either in the code or in the GitHub issue, but like, note, less max vertex count might improve performance. And then later on, when we wanted to perform improvement, we could just go through each of these notes first of all, and like things we had thought about previously but not spent too much time on. And that is extremely nice feeling. Render Goblin, because of how the world aligns up. The vertex is at 0, last vertex at 16. Okay. Program accounting indeed. Indeed. So, terrain patch. I want to do like index. I also want to do a private. Let's do it here. Private vector 3. Yeah, Profiler is extremely good for that. I hate the naming vector vertex. Do I want to call this vertex? Get vector int x int y. And I don't want to do a check here, I just want to do vertices, I don't think, index x, y. And for testing in build performance, I suggest using free asset Graphy. Dude, let's save that tip. Thank you, Fabric. So, Graphy for testing during build. Render Goblin, pretty much. It's just that I wanted my patches to align with 4x4, 8x8 worth of pixel data. Yeah, it makes sense, I think. Okay, so let's see here. Inbounds y, and here we do, if it is, we do get vector I j plus 1, otherwise get vector I j, and then we take this one minus in bounds y j minus 1, if so get vector a lot of checks, but it's basically, so we want to get north to south, we want to get this vector, but we also want to double check, so does this one exist? If it does not, use this one. And then when we calculate what we subtract with, we check, does this one exist? If not, use this one. So could probably, like, this is how we're gonna do it to start with. We're probably gonna fix this one so we can go remove these, so we calculate the normals for each point that is not on an edge, and then we have a different way to do it for the edges, because when we calculate the edge normals, we also want to like ask our neighbors for information, like, hey, terrain patch to my left, what is your edge vertices, and so on. But let's just do it like this for now. I've seen normal calculation or normal creation from height maps, but I've never done it myself. So let's go calculate normals. Let's also do bool detailed, I think. And here we do west to east, and it's probably going to be the exact same thing, but x. Okay, and then I want something like if detailed calculate diagonal gradients. But then if we don't do it detailed, it should be as easy as, do you plan to edit your height data on the GPU? The initial idea has just been to it's a good question. Like, in an ideal world, I think I would like to move most of this, if not everything, to the GPU. So editing or like deforming the terrain on the GPU would be very nice, I think. Like if the player terraforms, like makes the terrain go up, like the player is going to terraform the terrain using brushes basically, and if we can represent that in a very nice texture way, we can probably do the terraforming, like editing the height data on the GPU. That would be nice. We'll see. And is deforming the terrain a significant part of the gameplay? Yes, it is. It's not something that is going to happen all the time, but it is a significant part of the gameplay. Yeah. Okay, so if we do it like this, isn't it just... You can perform on GPU, but getting back the mesh data for collision will be a pain. Yeah, you're right, Fabic. But if we can do a custom collision, like if we can do a custom, it doesn't matter. If we want to do collision, we need the data on the CPU as well. That's true, but maybe we can do something similar to this. So when we set the terrain data here, we actually set it on the GPU. So we create a render texture and then we blit on the GPU, and then we read back the pixels from the GPU to the CPU. So one could think that we do something similar like to this when you deform the terrain, but we'll see. Cartoon SSTV, by the way, thank you so much for the follow. I must have missed it when it happened. But yeah, that is a big question. I want to do... I don't even know if I have a thought on this so far, but... what to do on the CPU versus what to do on the GPU. This, it feels like it's going to be a recurring thought. So I'll do terrain. So it's basically going to be this: do terrain alteration on the GPU first and send it and read it on the CPU, or do terrain alteration on the CPU and then send it to the GPU. Those two approaches, I guess. D-Sabbath, gotta be careful with Graphy. It uses a lot of string manipulations, and overhead from itself can give you skewed results. It generates a ton of garbage. Okay. Yeah, we're gonna have to do some research there. Cartoon SST, I love watching this. Happy to follow. Nice. Appreciate it. Let's see, Render Goblin. Well, sir, I will leave you to your productive day. I apologize for somewhat nerdy interrogation and curiosity. No. That's why I'm here. Like, nerdy interrogation. Is that how you pronounce it? And curiosity. That's what we want. So I appreciate it. Thank you for stopping by, and good luck on your productive day as well. I decided to keep terrain manipulation on CPU side just to avoid potential readback errors or GPU differences versus CPU. Oh, that's something you might want to think about. Basically, like, the idea I have right now is that terrain manipulation is basically going to be... it's basically going to be one texture applied to another texture by some shader, or by some shader, computational or graphical. I don't care. That's the idea I've had. And you can do it on the CPU, you can do it on the GPU, but it just feels like a task that the GPU is built for, you know. But sending it back to the CPU, yeah, that's at least like that's something I've learned that you want to try and avoid, but I don't know. Okay, let's see here. Thank you, Render Goblin. I'm gonna put that into thoughts as well. Need to read up on that. And we're gonna do this. I think I'm gonna run, and I think I'm gonna make myself a cup of coffee actually. So be right back real quick, and after that we will dive into this. Okay, back. Sorry about that. Let's see if this caffeine can give me some very needed strength. Okay, so now we have terrain without normals. It looks like this. So let's see if we can fix it. Oh yeah, I wanted to add one thought as well. Thoughts more like... Look into clip map terrain. Clod chunked LOD. I don't know. But I like to look into every tip I get. So let's see. So we have north to south, west to east. Now we want to do a normal from this. Which should be, so normals, index I, j is equal to, I don't even know how you do this on the CPU anymore, but we want to do this vector3 dot cross between north to south and west to east. Ooh, nice. Yeah, so we probably also want to do dot normalized. And that should be it, I think. Let's see if we get something. Actually, did we... Vertices false, yeah, let's see. Okay, now we have some light here. I'm not... It looks pretty okay, right? Where do we have the sun? Actually. Or does it? I want to be able to compare this in real time, so that's what we're gonna do. Try and implement it so I can just... Let's generate it during runtime if we switch any setup here. Fabric, don't use LOD if you're going to grab the meshes on the GPU. I draw walls that have 11k verts with no problem, and there are a lot of them. Okay. Okay. I'm taking notes, like relying on LOD for better performance is something I have thought I could do, but we'll see. Okay, garden, let's do... oh no, terrain base. Let's do private void on validate. And then also I want to set terrain patch, add component, terrain patch instantiate. Let's add instantiate bool test flag. And here we do go into lurk mode, have to grab some breakfast. I'd enjoy that breakfast, Fabic. Private bool test flag. So we're gonna do a lot of bool based tests here, so let's just add a test flag here as well, and which we can use a lot. And did we have it here as well? No. Test flag 1. Okay, so now we can switch that and we regenerate. And one last thing. So when we calculate normals, I want to do... Let's do this. If test flag else let's see if this works. So I should be able to just click check, uncheck a boolean here, and we should generate, regenerate. Okay, so now we have it generated during when we're not playing. That's good. So let's see, garden. So this is with our own solution. Ooh, we didn't delete the old ones. That's maybe something we want to do. Yeah, let's do terrain base on validate. Can we do game object dot destroy? Nah. Let's just do transform dot children. I thought we had something here for getting all the children. Get child. Are we gonna have to do this way? For 0 I is less than transform dot child count, and then we do destroy transform dot get child I dot oh no, what do we have? Destroy immediate. Okay. Or on validate, you must use destroy instead. Okay, I just want to see a difference here, so let's just do, let's not destroy them, let's do transform dot game object dot set active equal to false. And then I just have to destroy them manually, I guess, for now. So, let's see, test flag 1 is enabled right now. Which means that we do recalculate normals. So this is with recalculate normals, the Unity solution, and our current solution results in this. Actually not that big of a difference. I think we can go with this. So our solution, Unity calculate. I think, let's see if we can fix it so that we calculate the normal based on the diagonals as well. I wonder if you want to do it so you calculate one cross product here, you calculate one cross product here, and then we do something with those two, like interpolation. Let's see, from 4 vectors. Let's just do normals from height map. We want to do it from we want to do it in, what is it, 4 directions. Okay, so here we take center point and left, right, down, up from center point. Here we go. Okay, one sec. So this point really don't have anything in common with this point, since we're thinking about this as triangles. But do I really want to do that? Maybe I just want to do, let's see here. Normal is equal to this, but then we do, if it's detailed, we also do vector 3 north northwest to southeast. And here I think we want to do inbounds I plus 1 and inbounds y, or actually minus 1, right? West and north inbounds y I plus 1. If that's true, get vector I plus 1 j plus 1. Otherwise, get vector I j. Probably can simplify this one a little bit later on, and then we want to negate this with, we want to do exactly something similar, but we change the signs here. And then we also do vector 3, what is it, north east to southwest. And then it's plus plus minus minus. Although, let's see here. And here we want to do j, so there's a lot of things that can go wrong here. Oops. But j, j. So let's just double check. Inbounds northwest to southeast. West is -1. East, okay, so that's correct. And then I think we want to do vector 3 normal is I wonder if we want to do is equal to, or we don't want to redefine it, we just do normal is equal to vector 3 dot cross between this one and this one. And then the question is if addition is the correct way forward here, but if so, we do, so normal is equal to normal plus this one, and then with a normalize after. Or actually, we don't normalize yet. So we can just do normal is plus equal to this one, and then we normalize it here. And let's do test flag 1. Almost. So when we generate the normals, we send in test flag 2 here. So if test flag 2 is true, then we do the detailed version. If it's false, we do the simple version. And if test flag 1 is true, yeah. Test flag 1, test flag 2. Let's see, I need to check. Yeah, I want to go the other way around here. Okay, test flag 1 is off, test flag 2 is off. So this is the result of using Unity's normal calculation. Test flag 1, if we enable this one, we get our own simple normal solution. It's a little bit different here, but it's also a little bit better, to be honest. And if we enable this one, it's the better, our solution still, but the better one. hopefully. Yeah, I'm a little bit worried here. I'm not a big fan of the better one. I think something is not correct with that one. This one and this is pretty similar. Oops. But I don't really know which one I would say is the better one. This one looks a bit more smooth. I would like to know Unity mesh recalculate normals, how this one was, what kind of algorithm it uses. Normals are calculated from all shared vertices. Yeah, so I think it's this approach. This one is probably the better one. Which would explain the more smoother result, but which one does actually look better? This one here is a bit weird though. Ah, that's just a shadow artifact, never mind. Yeah, I don't know which result I like the most. So this is probably... I probably want to support all three. Like, I want to support this one, I want to support this one, and I want to support an implementation of this one. Felion PL, thank you so much for the follow, by the way. But if we want to do this one, it's going to be, let's see here, what do we actually do? This is the simplified version. So we get the height from 2 times the height to the one to the left, the one to the right, upright. Okay. But to be able to do this one, we need to figure out exactly how we build up our mesh, which shouldn't be too hard since we have this one here. So we do it, let's see here, we do it ij j plus 1, so this one, and then I plus 1, so but j still, so this one. So we do it like this, and then here we do I plus j plus 1 plus plus, so it's this one. So we do this. So let's assume that we do this for all the places like this. Modding Minecraft, can the boy jump yet? Yes, indeed he can. He has a very floaty jump animation, but he can jump. Okay, so if we get to this vertex, then we want to, the neighboring is down, left, up, right, and down, right. So instead of, it's not entirely, it's the other way around. So instead of upright, we have up left, and instead of down left, we have down right. So let's try this calculation right here. I want to take, I'm a little bit scared that we might get too many different methods, but let's do, for now, let's do public vector3 calculate normals using for calculate normals from 4 height values. Actually, how do I wanna? It's really not the height values we're calculating it from, since we, let's do calculate normals from 4 neighbor, not from, but calculate normals for neighbors. Yeah, whatever. 3 vertices, and then I want a function public vector3 calculate normals 8 neighbors. It's going to be a little bit of a duplicated code, but I don't care at this state. So vector 3, and here we do calculate normals connected triangle neighbors. Calculate normals for neighbors. That's just this one. Ooh, never mind. But let's see. Okay, calculate normals 8. So let's just take this one. And add okay, there we go. Let's get rid of this one. So now this one instead would look something like should do this with some flag solution instead, but yeah. We have an error here somewhere. Yes, there we go. Mesh.normals is equal to, and here I don't want to use this one because we have already tried with this one and it gives a smooth result. I'm a big fan of this. Might not be the correct one though. I'm a big fan of both of these. Now I just want to get this one to work as well, and like the goal is to make this one, so this one should look exactly the same as this one, because if I understand the documentation correctly, from all shared vertices it's this approach we want to take. And if this user is correct, it should be this. So calculate normals connected triangle neighbors vertices. So yeah, we want to start off, we want to do all of this, but this one is going to look way different. It's also a question of what do we want to do if we can't move up or down or left or right or whatever. So let's see, we want left, right, so if this is correct, we want left, top left, top right, bottom right. But let's rename them with a better naming convention. So middle left, top middle. So vector 3, top middle, or top center left is equal to, so it's in bounds center left x I minus 1 We can cache this one in each of these functions, I think, but yeah, this one specifically. So center left, vector 3, top left, and inbounds y j plus 1. Right, to the left, up, top center, what did we have? We have center right. And bottom right. Something like that, I think. And with these, we're gonna calculate the normal, and we're gonna do it by this one. So let's just copy this one. AXAY.
Change that beat up. Here we go.
This one we want to get right as well. So AX and AY, let's create it here. vector 2 delta. So what is it? It is dimension divided by resolution. I think we should be able to just do dimension divided by resolution. We've done this previously. We used this one previously up here, but we don't anymore. I think it's this one, and we don't want to do -1, I don't think, no. Okay, so what we do here then is, let's copy this one real quick. So is equal to 2 times top left. We actually want top left minus not top left, center left minus center right minus set upright. So that much must be top left for us, I think. I wonder if that will fuck it up. Like, we don't have the exact same. That might be cause for some issues, definitely. But let's try and take, so top left plus bottom right plus top center minus oh, we actually only have 5. That's not good. Meter 3, we also want, what is it? Bottom center. And we want to divide this one by delta.x. Yeah, this is also a new vector 3. And this is for the x, and then we want to calculate the y, but it's actually our z, I think. So many question marks, but I think we want 6 here, and we want the other one here. Philov 619, thank you so much for the follow, appreciate it. Are the parentheses correct? Yeah, I think so. Although I'm a little bit... Okay, that's... And the second one is... RDNH down, up... Okay, let's just do it. 2.0 f times. So bottom center minus top center plus top left plus bottom right minus set up, what is that? That's top center. Whoa, 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 whoa. Does this make any sense? I wonder if this one should be said right, actually. Or let's just go with top center for now, and yeah, I'm pretty sure center left. Yes. And we want this normalized as well. I thought we should be able to. New vector 3. Fuck. Okay. Not convert. Ooh. Yeah, that is true. Oh yeah, it's only the Z we want here, so it's basically or the Y. So we want to do we want to do dot Y on everyone here? Maybe we do. Okay, many question marks. This one, probably wanna change this one. But also, we're doing top left, bottom right instead of top right, bottom left. Wonder how much that actually changes our result. Let's see what we get by this so far. So. If test flag 2 is on and test flag 1 is off, then we get this one. Let's see. So, this is using Unity's normal generation algorithm. So let's see what happens if we do test flag 2. Yeah, that's quite a heavy difference. I think let's try and do this one. I think this one should be said right at least. This one's answer has a mistake. I'm not entirely sure. Still, let's see. I just want to try and see what it looks like if we do. So center left, center right. still. Not even close. So, what is the logic behind this? Let's see. Or actually, maybe I should try this one. Up, left, up, right. Yeah, let's just try and do this. So, see if this one leads to the correct result, because this one, that I understand, doing the cross products. The simplification, I'm still, I don't know. Actually, we want to go back more. We want to do there we go. So what we want to do instead is we want to calculate a hell of a lot of cross products. So vector 3. Let's just name them n1 to n6, and I guess. And let's copy this one. So up is top center, or actually top center and center left. Top, we don't have top right. So I wonder if we want to do, we have top left, so we want to do top left times up and left times top left. I think so. So what do we have? Top center, center left. And then we do top left, top center, center left, top left. Down and right, so bottom, center, and center right. And then we don't have down left, we have bottom right, so bottom, right, and bottom center. And I don't know. What do we have? Center right, bottom right. So normals at index ij should be equal to n1 plus n2 plus n3 plus n4 and normalized. So what actually happens here? So for this point we take this, so top center, center left, this one, we do cross product, okay, that's nice. Then we do top left, top center, we do cross product, and then we do center left and this one and do cross product. So we get 3 normals based on these, and then we do the same for this. So we have 6 normals in the end. We just add them all together and normalize it. So just a way to average them all, I guess. Let's see what kind of result this yields. Good morning, E-Dragon. So this is Unity's approach, and this is this approach. It's still a little bit off, although a little bit off here as well. I wonder why though. I think it's the closest one yet. I do understand why it's a bit off here. I guess the Unity approach just ignores. Our approach gets, like, at the edges we use the normal vector. Maybe we should just skip this one. So I do understand the small changes we get here, but I'm not too sure about the changes here. Too bad.
Is everybody in the groove? Stick around. We're just warming up, baby.
Ooh, it's unsmooth as hell. I wonder why. This is unacceptable. Test flight 2. Like this approach I get this. I'm just a little bit worried about this. We shouldn't be seeing this right here, I don't think. That's weird. But we do get the same artifacts. If we do test flag 1, that means that we get this one. And here we do... Yeah, I'm gonna try something a little bit different here, I think. What do we have? We have... Yeah, I think I want to try... Like, okay. This approach, test flag 1, also gives artifacts here. And I understand that. I think it's because we're only going left to right and up to down. For test flag, so we get some, we use less data, that's why we get some artifacts here. Test flag 2 uses more data, or should be using as much data as Unity's approach, but we do get a lot of artifacts here. It doesn't really make sense. Like, it's weighted differently. So I wonder if we want to do... We have this point, this... We have this point, this point, this point, this point, this point, this point, and this point. We just want to calculate the normals here on based on every connected vertex. So we don't have this point either, sorry. This, 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 and this. So connected, connected, connected. Pretty sure that's what. After modifying the vertices, it often normals are calculated from all shared vertices. Mm-hmm. Cool. So I think we want to do something similar as I wanted to see what happens if we take top minus bottom, this one minus this one minus this one, and then we do a nice cross product in some way. I don't know how that would look with two like this. Maybe let's try it. So I wonder, instead of doing this, I wonder if we can do vector 3 and 1 is equal to vector 3 cross, and here we do top center minus bottom center, center left minus center right. So that's our n1, and then we do vector 3 n2 is equal to here we do top left minus bottom right, center left minus center right. And the normal then is equal to this. Oops. Are you tinkering with terrain creation? Yes, E-Dragon, we are. And right now we're testing a different approaches to generating the normals. I think it's going pretty good. We want to do that. Delete. So we have this garden. Let's do 0. So this is unities. Recalculate normals. Irfan, what's up? Test flag 1 is... Okay, that's the simple solution. Just north to south, west to east. Test flag 2 is this one, so it's basically cross product between top center to bottom center and center left to center right, and cross product between top left, bottom right, center left, center right. Let's try it. Ooh, I think it's as close as we've gotten, but it's darkened in a weird way, so I wonder if the normals are in the wrong direction. So we probably want to do we want to go bottom center to top center, or is it center right to center left we want to go? I don't know. Yeah, I think they were... So it looked like the normals were flipped in some weird way. There we go. It's almost correct. Could it be that they are still flipped? Do we want to go... Do we want to flip this as well? It's a little bit weird because here we get the exact same but just a bit darker result. While if we don't flip it, we get... So maybe we want to do... Or actually, let's instead of trying to brute force this, I might want to see if we can logically solve it. This is not correct. So this one, let's see, what do we do? Bottom center, so this one minus top center, so we get a vector in this direction. Center right minus center left, so center right minus center left, so we get in this direction, right? That should be correct. And then we do top left bottom right, so top left bottom right. So this, and we do center right, center left. Center right, oh actually. Top left minus bottom right, so we get this one. And center right. This one, and that's wrong. So yeah, we want to do bottom right minus top left, right? Trying to get close as possible to Unity solution so you can customize it even more. Yeah, like that's one reason, but the biggest reason is because if we rely on Unity's solution, we are gonna have a hard time solving the normal overlap or the normal difference between patches of terrain. So to fix this one, the easiest way would be to handle the generation of our normals ourselves. Yeah. But for some reason I can't get like the exact same result as Unity's, which is, this is still weird. Like the shading is exactly the same except we're getting a dark result here. That's weird. Or it's not entirely the same. That's true. Fuck. I'm pretty sure we want to go top center minus bottom center. And still don't know. Top left. Okay, so we only get a tiny difference here, and I'm not entirely sure why or what. Closest one yet, but it's some weird artifacts here. That I'm not a big fan of. Actually, we can also compare it to, let's do terrain base, serialized field private, bool, test flag 3. So test flag 1, test flag 2, else if test flag 3. Like, if I'm gonna be totally honest, I think this test flag 3 gives the best result. So the calculate normals using 4 neighbors or 8 neighbors or just connected triangles. I think this one gives the best result, if I'm gonna be honest. So this is unities. Like, isn't this a smoother result? Or is it... Ah, maybe it... So flag 1, full of artifacts. This one is the best one, right? Or... but are we losing data here? If I want to see how, let's remove that one and let's try stylized material grass. So this is the Unity normals. There's barely any difference. Ah, there is a little bit difference, but which one is the best one? Jesus. Indeed, Cypher, indeed. Ah, it's annoying that I can't get the exact same result. I think Unities is probably better. I'm looking at this area here. Get some weird... Yeah, there's so many things where I kind of gone wrong, so to speak. Is this really, like, what do we... ij plus 1, I plus 1j. Yeah, we create them like this. Would love to get some more insight into this one. Flags. One sec though. Center, right. Still not sure about this one either. We do the same here. It should be okay, it should be okay. Welcome back, Fabic. What have I missed? Have you tried Mesh Optimize? I have not tried Mesh Optimize yet. We're still working on normals. We have a few different approaches to calculating the normals, but none of them gives the same result as Unity's calculate normals, so that's a little bit weird. Do we want to go? Yeah, the way we do, it's probably just an issue of the way we do the cross product. So if we have a mesh that looks like this, which we unfortunately don't have, yeah, exactly. Like instead of this, we have the diagonal going in the other way. I wonder if we want to change that so it would be. So let's say that we want to change. We want to change it to this instead. So So we just want to do j plus 1, j plus 1. And is it like this? Let's see. I, j plus 1, I plus 1, j plus 1, and then we do I plus 1, j plus 1, this one, and then down to I plus 1, j, and ij. Let's go. But then we need to do some additional changes here. Let's see. So now we have the same here. So instead of top center and top left and bottom right, we now have what is it? Top right and bottom left. Top right, bottom left, which is the same as this one, if I'm not so top right, by the way, is I plus 1, j plus 1, right? And bottom left is bottom left, I minus 1, j minus 1. What's up, Absurd Noises? I've been pretty good. How about you? When was the last time you dropped by my stream? Wasn't it like last week or something like that? Maybe the week before. Okay, so now we have this. Now we have the same mesh pattern as this guy. So let's see if it's the correct. So up times left. So top, center, center, left is correct. And then we have, oh, actually I have this one here. Up, right. So top, right, up. And then we have, oh, yeah. Then we have center, right. Top, right. Then we have, this is N4, bottom center and center right. And then we have bottom left, bottom center. And then we have center, left, bottom, left. Let's try this. All good, bro. Almost 2 weeks ago. Been busy couple of weeks. I watched on YouTube your progress, but not everything. Oh, thanks you. Thank you. I appreciate it. But is the stress starting to go down, or are the next couple of weeks going to be as busy as the previous 2 weeks? Okay, let's see what kind of result we get from this one, by the way. So triangle neighbors is test flag 2. So this is Unity's default, and what was it? Test Flight 2, right? Should probably have named these better. Test Flight 2, yes. Come on. Okay, so one of our direction is probably wrong. I wonder what gives us the inverted normals. Am I not doing all of these correct? Up, left. Top, center, center, left. Fuck, I should have named these better as well. So instead of doing XY, they were actually named YX, which is pretty weird. Bottom left, bottom center, center left, bottom left. That seems to be correct. We'll see. We're changing our focus in our studio, ceasing production of mobile games and focusing on our Web3 project more and more. Okay, interesting. So how is it working with Web3? Is it nice? I think I'm pretty much doing this in the correct order here. We're just not getting the correct result. I watched someone explain to me the difference between like Web 1, Web 2, Web 3. Like the different ways, what defines the different quote unquote versions. Still not entirely sure.
We're just warming up, baby.
Looks pretty damn similar, except for the something being in the wrong direction, I think. Okay, fuck it, let's do... What do I want? I want up. Let's make sure that this is actually the correct one. So let's just up. We do j plus 1, I, j plus 1. Okay, that's up. Great. And then we do bottom center. This is down. J minus 1. J minus 1, and then we want to do center. Let's go center right first. So this one is right. I plus 1, I plus 1, and then we do left. I minus 1, I minus 1, and then we want to do top, or what is it then? Up, right. So plus 1 for right, plus 1 for up, we have plus 1, and then we want to have down left. Now the naming should be correct, and this one is minus for the left, minus down, minus minus. Okay, so now we can use the exact same, so up, left. Up, right, up, right, up, right, down, right, down, left, down, and left, down, left. Great. Probably no difference, but we'll see. I still think this one gives the best result, if I'm gonna be honest. But so what do we have? We have quads like this, and we split it up like, what to say, down left and up right, so like this. And right now we do the cross between up and left, so this one we do cross between this one and this one, top left. Then we do up, right, and up. So we do this one and this one. Then we do right and upright. Oh, actually, upright and up. So it's this one and this one. And then we do this one and this one. And then we do down and right. And then we do down, left, and down. And then we do left and down, left. Might want to color the first one in each of these. So up, right, okay, right, down, left, and left. Don't we want to do want to do up and right here? Up, right, up, up and right, up and upright, upright and right, right and down. Jesus. Hey yo Herman, thank you for the follow, appreciate it. Absurd Noises, is it nice? Yeah, it is. Totally different world. Let's see. Oh, nice. Yeah, that's also my rough understanding of Web3, that it's decentralized. Yeah, right now I'm just trying to make the normal calculation. So we're generating terrain and we want to generate it with the correct normals. So right now I'm just trying to generate the normals in the same way as Unity's mesh recalculate normals would, because I want to be able to generate the same normals, but I want to like extend it a tiny bit as well. But unfortunately we're not getting the same normals, and I wonder why. And I think it's a little bit weird here that we're doing left, right. I wonder why. Do we want to do more here? So we're doing, yeah, maybe we want to start with this one. But maybe then, so we do this one, then we jump to 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 this one, and then we jump to this one. Okay, maybe that's is correct actually. Yeah, I think it is. So we want to move in clockwise, but I think we want to change which one. Like the red ones should always be. I wonder if we want, like, I think we want this one to be, let's see here, this one to be the first here, then this one, then this one, then this one, then this one, and then this one. I wonder if we want to do that. Right now it's like up, up again, right, down. It feels a little bit off. I had exact trouble once when I was writing procedural hills. Yeah, it's like a rite of passage, you know. But I think we should be able to get to the bottom of this. So, me with my so-so terrain normal generation knowledge probably would change the order of, or maybe like you either want to go this or you want to do blue. I think we want to do it. Don't you want it to be? One sec. Up, right. Yeah, then we get to double there. Yeah, I think we want to go this way. So, I wonder if this is correct. Instead of going up left here, we want to do left up. And instead of doing up, right, up here, we want to do up, right. And then we want to do up, right, and then we want to do up, right. I don't know. Right. And then we want to do right, down, left. Don't you want to keep? And then we want to do down, left, down. Don't you want to do it like this? What's up, Coolers K? How's the grass going? Hey, the grass is last week's news. Now we're doing terrain generation, you know? How are you doing? Let's try this, see what kind of weird result we get with the normals. So this is Unity default. Looks a little bit dark, but yeah, Unity default. I think this is the worst one yet. Definitely. Generation terrain. Yes, indeed. Okay, so this is not correct at all, but like what we did here is not correct either. Maybe we want to do so one of these are in the wrong order, that's for sure. Up, let's see, up, right. I don't really understand. It might be noticeable by the way I'm brute forcing this, but I'm not entirely, like, I don't understand exactly what the order is based on. And what causes this issue. Like, I know that one cross product is the wrong one. You can see what, like, we're getting the exact same shading, but a little bit darker. Yeah, the wire is just like this. So by doing it this way, everything looks to be alright, but we get it in a little bit of a darker shade, right? Select all meshes. So it is entertaining to watch someone else have issues that I had back in the day. Yeah, I know. Ignore the hard edges. Ignore the hard edges, absurd noises. We know why they have hard edges. If you're talking about these. If you swap the order, you basically get the negative normals. Yeah, exactly. That's like, if we take a look at this one, I see if we generate it with this approach, like we get a darker shade, that's probably because the normal is negated. And I wonder which one of these cross products is done in the wrong order for us to get a negated normal. I don't know. You certainly always want the red arrow to be either after either before, but you swap it so same also. I get what you're saying, absurd noises, but okay, let me put it this way for you, absurd noises. Think about it like we're only working with this terrain. We're only working with this one. So this is what we're working with, and when we want to calculate the normal for this one, and we have a few different solutions. Right now we have one where we take this point minus this point, and this point minus this point, and we cross product those two values. Gives a pretty good result, but not as good as Unity's. We also have a solution where we take this point minus this point, this point minus this point, this point minus this point, and this point minus this point. And then we do cross product between this, and cross product between this and this. And then we add those two and normalize. Also, that is my favorite solution. I think it gives a very nice smooth normals. The third solution, the one we're working with right now, is we only take the connected vertices. So if we want to calculate the normal for this one, we use this one, this one, this one, this one, this one, and this one. So 1, 2, 3, 4, 5, 6 different vertices. Because I think that's what Unity does. But we get a negated normal, right? Because it's a little bit darker. So the problem we're trying to solve right now has nothing to do with this cleavage here. I hope that makes sense. So we can also compare. This is the Unity approach. Look at these these artifacts here. I don't know how good they are on stream. Looks like shit, right? But if we take, I think it's this approach. We still have these issues though, but this one is the closest one yet. This one, okay, this one is actually the closest one, but we have negated normals, or something is negated, and I wonder why. Do we just want to do this the other way around? So we want to switch this one and this one and this one and this one, maybe. Does that make sense, absurd noises? Like, the actual difference in normals between terrain patches is nothing we care about right now. That's something we're going to solve later. There we go, there we have it. Now we have the exact same fucking normal generation as Unity. Beautiful. Beautiful. There's no difference, right? Yeah, beautiful. Whew. That's fucking great. Okay, so I guess it all came down to one. The person giving the solution works in a left-handed coordinate system. Could that be it? And we're working with a right-handed coordinate system. Maybe. Yeah, like the reason we are doing this custom normal calculation is because in the end we want to get rid of these mismatches. But we're a few steps away from that right now. Okay, so this is good. Now we have 3 different ways to calculate the normals. Using 4 neighbors, using 8 neighbors, using only the connected neighbors. Beautiful. So I wonder, is this actually the best result? Like using 8 neighbors. Any particular reason why you're not using the height data? It will solve the edges between patches for free. Yeah, the idea is that this patch and this patch will have different height data. Right now they use the same height data, but they will have different height data. And so, okay, I guess, so what you want, like instead of asking for this, so when we calculate this here, instead of asking for this patch vertices, we can ask for the height data instead. Or am I understanding you correct? Yeah, we could probably use, I don't know what the pros and cons are. Instead, so when we calculate the normal here for this one, it's just a question of asking this one for its edge vertices or its edge pixels, right? I don't know what the difference really is. I'm just happy that we properly re-implemented Unity solution. Very nice to have the exact same normal calculations, but done by us. Like if these patches, if all of these patches used the same height map and the height map was as big as all of them together, then I understand just using the height map data and we would get no problems here. But the idea is that each of these patches will have its own height data or terrain data, and if that's the case, they need to communicate in some way. Before we continue, I just need to run AFK real quick. But when I will get back, we will continue. So, be right back. Okay, back. Sorry about that. So, it might be, as Harukanan said, might be cleaner to do the communication between terrain patches with a height map instead. So like, the only thing we really want to communicate between the patches are the terrain data. So we might just go with that one. If you're generating the height map procedurally, it would be easier. Yeah, so that's unfortunately not what we're gonna do. But like, I still think like doing it with the texture is probably better. And if we do it with the texture as well, like right now we mimic the Unity way of calculating the normals by doing this, which is the unoptimized way. We could do it this way instead. AXAY. Let's see if we can make this work again. Because if we do it this way, then we're only working with the height, of course. So that means that we don't even, like, we only need a height map. So let's do this. Try and make it work again. But we're gonna work with the vectors for now. But it would be, so we have delta, so it is normals, index ij is equal to new vector 3 dot normalized. And it's here we want to do something like this. So 2.0f times, let me just copy this one. Times left dot y. And here now we're back at we might want to do a lot of these the other way around. Let's see if we can make it work. So let's just copy how it is right now. Upright. Divided by delta.x. And we have 0 here. Or actually not 0, but 6. And the last one should... I also think it's an error here. Down, up, plus upright, plus down left, minus up, minus... Oh, we want... Yeah. Minus... left, and we want to do something like this, but I think this will give the wrong result, possibly because of this one. And for the same reason this gave the wrong result previously. Well, we'll see. This was not what I was hoping to see. This is actually it's almost, but not really. So wonder if this one wants to be, should be right. Am I really going to have to calculate this myself, do this simplification myself? That would suck. Can Wolfram Alpha simplify this for us? So how would I even go about writing this one here? Cross. Can we do that? See if we get some simplification. Wolfram Alpha cross product. I want to get how I write it. Oh, so can I actually, let's see. So if we do 1, 2, 3, 3, 4, 5. Right. Okay, so I wonder if I can do up.x, up.y, up.z. Would be nice, would be nice. We can't do X, Y, Z, A, B, C. Oh, but we can. Okay, so let's go. A dot might have screwed it up. So A. Up 1, up 2, up 3. But it's left we want to do first, okay. Left 1, left 2, left 3. Okay, that's correct, right? So now we should be able to just do... We want to do these 5 more times. L, U, 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 R. Okay. Let's see if Wolfram Alpha is able to simplify this for us. So we want to do this up and upright. So up, upright. Let's see if what the fuck? Cross product should have precedence, right? As soon as you have more than... Maybe we need to do A here. Like, as soon as you have variables with more than one name, or one... Okay. Let's see. So left, upright is A then. So then we have plus A, 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 and right is R. And then we do, so that's this one, R down. D and B. I sure hope this works. And then we're at this one. Down left, that's B. And left. Okay, let's see. Okay. I thought it would be able to simplify it, but maybe it wasn't. Jesus. L1 U3. I'm very interested in how this could be simplified to this. Or actually B3. Do we even have any term we can remove here? I don't know. Like, doing this calculation is so much more preferable than doing this. Unfortunately, I don't know what. This makes... I'm still... Okay, now we're back at... It's exact same, but darker. So now the question is, what did I change? I'm a little bit minus plus. I wonder if I wanna... What happens if we switch that one as well? Or do we want to do... I don't know. Okay, it's pretty much exactly the same again, except for... Yeah, okay, beautiful. I think this... Actually... Yeah. Fucking great. I think it's... is it the same? Yeah, I think it's the same except for at the edges. And the reason for it not being similar in the edges is because we do this. So if we cannot get a vertex because it's outside of the patch, then we just return the vertex in question, which means that it's a little bit skewed. It's a little bit weighted against the this vector, basically. But I wonder, did we have this problem with this solution? If not, then that's a bit weird. It should be... It should exist here as well, I think. But it doesn't, right? This one is exactly the same. Edges as well. This one is not. Okay. Interesting. I really thought it was this. It is probably that, but for some reason it's more apparent in this simplified version. I wonder why. Very interesting. Up, down. I'm just gonna guess something here as well. Very weird. Yeah, I mean, you're pretty late. So instead of doing this, we do this and almost get the same result. Could it be... Actually, we don't get anything on this side, do we? It's a little bit of a difference here. I'm starting to think that... I'm starting to think that this term here Mm. Still, I find it very weird that this result and this, it gives the same result except for this one being, the values being a bit washed out, so to speak, at the edges. That's weird. That's the only difference we get. What's up, Simon Game Dev? So, why? Just fighting with terrain generation, you know. I'm live in 3 hours. Have any tips? No, sorry. I don't think I have any tips. Or maybe I do. Good question. But nothing that I can think of right now. I'm way too deep into this terrain generation stuff to be able to think about anything else. Am I going to have to calculate this by hand? I don't understand though why Wolfram Alpha couldn't simplify it. And my guess is that this one is the culprit, maybe? Or actually, up, right, down, left. What's up, modding Minecraft, messing with terrain? Yeah, trying to at least. Trying to. Like, if we can make this simplification work, if we can rely on this one giving us the exact same result as this, that means that we only need the height value. And if we only need the height value, then we only need to communicate the terrain data texture between terrain patches instead of actual vectors. Fabic, may I ask why you're using 6.0 for y value? That's a good question. So, like, most of this simplification comes from this answer here, which is very good. And it's about... It's pretty much if you write out all the calculations happening here and here. So this plus this plus this, etc. And you write them out and then you simplify them because some of the terms take out each other. According to that user, you should arrive at something like this. So, yeah. Shouldn't it be your height map Y? Is that so? I'm not saying that not the case, I'm just trying to figure out why that would be the case. Maybe it makes sense. So what you're saying is that it should be get vector ij dot y. It's like you're putting in a const there, which is confusing me. Yeah, it's confusing me as well. Modding Minecraft, if you manage to make it work, will you make it save the terrain as well? Yeah. But persistency is something for the far, far future. But you are right, that constant there is confusing, like... But... Yeah, the constant is confusing indeed. I guess I'm just gonna have to sit down and simplify this with pen and paper. It's pretty much this, or this I want to simplify. What do we do? Left, up, up, right, right, down, down, left. Okay. Utkar's vectors question mark vectors exclamation point. Yeah, we're just trying to re-implement mesh.recalculate normals basically, but and we get it to work. Then we want to simplify the calculations here, and this sorta works, just a tiny bit of a difference at the edges of the terrain, and it sucks. Unity approach, our approach. The only difference is the normals at the right at the edge, and we don't get that difference if we just do this instead. So something is wrong in this simplification. I just don't know what. Oh, you think delta dimension? You think the delta is wrong? Fabic? Yeah, maybe it is. So we want to go, or is that it? It would be insane if you got it. Utgars, can we do post-process smoothing of edges if possible? I don't know what you mean exactly. Everywhere we're adding 1 to the resolution except for here. You're definitely correct. Damn, those... So many times I fall victim for that. Let's see if it has something to do with it. Still off. Is it more or less off? Delta, delta, delta. Restart Unity, it probably cached some values. Are you sure? Just trying to figure out if... Do you really think it would cache some values here? Is it worse or better? Yeah, it's hard to tell here as well. Let's do... let's try and do it like... Let's see here. Let's do... Okay, so it's this one we're working with. Let's just do... Let's do this. So if test flag 1, we're doing this one. And if, and here we do, if test flag 2, let's see here. Test flag 1 normals, then we do this. Test flag 2, then we do this. So by default we do this one. If we do test flag 2, we add 1 to resolution. Right? Let's see if we can see some difference in real time here. Okay, so this is Unity. This is our solution. It's a little bit brighter here. Our solution 2. There's really no difference whatsoever. That's weird. Yeah, no difference. Vector 2 int 1 times 10. One sec though. Let's see here. There's a little bit of a difference. I think it's visible on stream as well, right? So yeah, I'm pretty sure this is the correct way to do it. It's just that this one is so big that it's barely noticeable if we have +1 or not. Yeah. Although okay, so the hard truth is that if I just write this down, put it down, like I replace these values with these, write it out and simplify it, I will probably get to something like this, but with a minor change. It's just that okay, what bothers me though is, okay, so to make these work for us, fuck it, normalize the delta. You think? Oops. Yeah, just exaggerated normals, pretty much. There's so many things that can be wrong here. So like, what's happening here basically is that he has done a simplification on a cross product, a series of cross product that is in a different coordinate system. And I think he has done like 1 or 2 mistakes in that simplification as well. So like, my safest bet is just to my safest bet is just to, because we know that this one works. So if we comment this one out, I do want the simplified version though for performance, and this, it allows us to only work with the height, I think. But like if we take a look at this, this is the Unity, this is our solution. So if we just do these cross products, add them together and normalize them, then we get the correct result. It's just, I want a simplified approach. I find it quite weird, however, that, let's see here, that this one gives exactly the same result as this one, except for the edges of the map. That's, I don't know what to make out of that. Like why that is the case. So like in the center we get the exact same normals. On the edge we don't. I should be able to deduce why and just change what that is, but like I think it has to do with this. Like this, it works. I should be able to see why, but I can't. Also a little bit annoyed that Wolfram Alpha couldn't simplify it. You can take the painful approach and draw a gizmo for each norm and see which are wrong. Yeah, definitely. But like we can see, like it's just these edge ones. It's very annoying. And just in the case of when we simplify it. Yeah, looks like off by 1 in that simplified version. Yeah, it's just 1. This is the problem with relying on other people's simplifications. Like, fuck. Am I really gonna have to do this? Yeah, maybe. So it's getting close to that time where I have to give up for today. But I'm gonna continue tomorrow. But I will try to get the time later today to just simplify this myself and fix the issue here, so tomorrow on stream we don't have to sit with this anymore. Like, I want to have this method in place when I start streaming tomorrow. That's the goal, at least. It's gonna be so nice if we can get this one to work, the simplified version. Because this one is purely height map based, so when we want to fix the normals on the edge here, when we want to be able to remove this cleavage line that is visible even with unities, we just ask the neighboring terrain patch, we just ask for their texture pretty much, or a few pixel values, instead of asking for vertices and stuff like that. And I think, I'm pretty sure, if we can get this to work, we might also be able to generate the normals in here, I think. Do we want to do that though? We'll see. But yeah, I'm gonna try to get this correctly simplified until tomorrow's stream, because now I have to run, unfortunately. So, as always, thank you for sticking with me. Thank you all for watching. And hopefully I will see you tomorrow again. And have a great rest of the day.